Hello everyone. In this video, we will discuss distance time graph and velocity time graph for three different cases. When the object is at a rest condition, when the object is in uniform motion, and when the object is in non-uniform motion. So distance time graph and velocity time graph, togetherly we will compare for all three cases. First, we will start with the distance time graph for object at a rest condition. Just for our understanding, we will divide this time or this x-axis in four different parts. One, two, three, four parts. Now suppose this pen and the distance of this pen from me, it is 1 meter at morning 10 a.m. Now again after 10 minutes, if I measure the distance of the pen from me, still it is 1 meter. After few more 10 minutes, again if I measure the distance of this pen from me, it is still 1 meter. So what I want to say is, even though time is progressing, time is increasing, the distance of this pen from me, it remains the same, which was 1 meter. Irrespective of time, the distance is same. Means when the time was zero or initial time what we have taken, at that time the distance, this is the particular distance. Again, after some time, if I measured the distance, this height, I'm saying about this height. So this height is same. Again, after few more time, if you have seen, the distance is same. After a few more time, still the distance is same. After a few more time, still the distance is same. Now, if I connect the points, corresponding points of distance and time, this line is a straight line and this straight line is parallel to the time axis, or this straight line is parallel to the time axis. So this is for distance time graph. If same methodology, if I go with same methodology, if I go for velocity time graph, again the same pen we will take, and as we know the distance of this pen from me was 1 meter. That thing we have taken for distance time graph. Now if I think for velocity time graph, now morning 10 a.m. suppose velocity of this pen. What is the velocity of this pen currently? Nothing. Zero. Now again after 10 minutes if I measure the velocity, what is the velocity? It is zero. Few more 10 minutes if I measure, still it is zero. So what does it mean? Even though time is progressing, time is increasing, velocity of this pen or velocity of this object, it is not changing at all. It is zero. Initially it is zero. Finally also it will be the same. It will be zero only. So again, we will divide the time interval in four parts. Time is 0, velocity is 0. Next time, still it is 0. Few more time, still it is 0. Few more time, still it is 0. Few more time, still it is 0. These points actually indicates velocity and time. Corresponding velocity and corresponding time only we have taken. But for any time, velocity as it is 0. And now if I connect these points, what I will get it? I will get a graph, what I have shown in yellow color. So that graph is actually, it is parallel to this, not parallel. I will say it is on the time axis or it is on the x-axis. Here, this graph, this distance time graph is parallel to the x-axis and at some distance from the x-axis. But here for this case, this velocity time graph is on the x-axis or on the time axis. So this is about distance time graph and velocity time graph for the object at a rest condition. Next video we will discuss same distance time graph and velocity time graph for uniform motion when the object is in uniform motion. Thank you.